tracking throughout the course of the day a potential conjunction with a piece of orbital debris. We are expecting updated tracking information on this object a short time from now. At the moment, it poses no concern for the safety of the crew or the spacewalkers outside, with the potential time for closest approach of this object well after the expected end of today's spacewalk. But we're monitoring it closely and monitoring it in conjunction with our Russian counterparts before any future action is taken. Again, the call from Kanalakos to Jessica Watkins on board the International Space Station about the potential for a debris avoidance maneuver later in the day after the spacewalk is completed that would put us out of the vicinity of a piece of orbital debris that we have been tracking for the past few hours. At the moment, there is no concern and no action that will be required unless future tracking updates dictate otherwise. We'll keep you posted as we move along throughout the course of the afternoon. As we approach the 4.5-hour mark in the spacewalk, we are watching a variety of actions by Oleg Artemiev and Samantha Cristoforetti outside of the International Space Station as they work along the Naoka multipurpose laboratory module. They're in the process of removing and replacing a protective window from the camera light unit, one of two such units that are on each end of the 37-foot-long European robotic arm, along what are called end effectors, or the hands, if you will, the grappling mechanisms for the robotic arm. And they are reconfiguring a device called an EMMI. That is the acronym for an external control panel that operates the robotic arm's functioning from commands that can be sent from spacewalkers operating outside of the International Space Station. They're putting that control panel into what is known as a stowage mode that will basically put it in hibernation in preparation for its relocation on a future Russian spacewalk. It'll be relocated from one base point or a fixture point to another on the Naoka multipurpose laboratory module. And there is that external control panel. It looks like a suitcase with the lid open.
Turning off the camera. Samantha, how are you feeling? We are at 3.5 hours mark. I'm feeling well. Okay, only 2 bars left on camera charge. 21, 22, 23. We will need to maintain 1 bar for imagery after panel ops and after protective window. We will also need the camera for a platform with adapters in the airlock. Well, we have 3 bolts and handrails too on the node module. Okay, I will hook you up to a clean handrail with nice numbers. 4565. Now hand me your second hook. Yes, swap it like that. Hold on with your right hand and use your left hand to hand me the hook. Okay, I'm moving you away from the thruster. Excellent. Now control your position a little bit to the side. Hold on. Now go. You see, this line is contaminated. but these engines, these thrusters have never been fired, so you can use them to push against. Okay, hold on, I'm going to move to the side and help you. Okay. Okay, like this. There we go. You can release your hand. You are already tethered. That's it. Artem, standing by for your go for panel ops.
Сейчас, секунду.
Let's...
Ты понимаешь, что тебе надо делать дальше? Вот
Okay. Before we do that, Samantha, you now have to be on plane 3. There are 2 MLI flaps that you need to close. Yes, I see them. Okay, Samantha, please proceed with this operation, and when you are complete, come back. And in the meantime, Oleg and I will start executing the further cheat sheet. Okay, while we are talking, the handrail.
Так, давай приступим тогда. Первым делом шпаргалку.
Okay, Oleg, let's start. Take the cheat sheet. Take it with you. Yes, go ahead, Artem.
Да, первым делом мы выключаем тумблер питания.
So, first we flip the power switch. Okay. Turning off the power. Power switch is off. Everything is off. Copy, all LEDs are off. Copy. Now turn on the power switch. Done. LED is green. Copy. Then on the display, go to menu. Reading the menu.
Принято.
Copy.
Теперь тумблер старт-стоп.
Now put the start-stop switch in the stop position and keep it in this position for 2 or 3 seconds. Copy, start-stop switch in the stop position, holding for 2 seconds. Complete. Copy that, Oleg. Now, on the display menu, you will see auto menu, language selection, options. Yes.
Тумблер старт-стоп в положении старт.
Copy that, Oleg. Start-stop switch to the start position. Copy, holding 2 seconds. And I confirm select menu showing options for the bus and ECC. Copy, now put start-stop switch to the stop position. Copy, holding for 2 seconds. Complete. Okay, I see selection for star ID, and I see the option for my ID. Copy, start switch to the start position. Copy, holding for 2 seconds. Complete. Question. Start, no, yes.
Тумблер старт-стоп в положении старт.
Copy, start-stop switch to the start position. Copy, holding for 2 seconds. Complete. Menu is off. Checkout.
Выполнение проверок.
Bus checkout in progress.
Rom, checkout, running. Принимай 1, CPC, English.
Ждем загорания всех дисплеев.
So we're waiting for all the displays to come alive. Standing by. Turned off, and now they're turning on. All the windows of all the displays. Check out start. So it proposes that I press start,
Variable data.
and you should see the parameters on the display. And what messages do you have? Could you please repeat? Parameters of the display. Which message do you have on the display? Parameters of the display. Variable data. Oh, nothing. It's empty.
Там нет сообщений M.
You don't have MMI or anything else? Nothing? Oh, that I have, yes. In those parameters, variable data, there is upper window is empty. The rest of them are all filled out. So everything we've had before, we still have them. Okay, toggle switch start stop in the position start, copy, start. Now it proposes to press stop. And I have caution and emergency in red. Are they all lit up, all the LEDs you mean? Yes, let me see. I'll tell you what is lit up. So these are lit up. Give me just a second. I'm looking and monitoring all the displays of the control panel. Okay, GK is not on. All the other LEDs are lit up. GCC is not lit up because of the sun. I couldn't see. Откол TK is not lit up. That is correct. I confirm.
Подожди секунду. Можешь?
Oleg, please stand by. Okay, now it's working.
Заработал.
And now it's Откол TK. I didn't do anything.
Так он заработал или погас?
But now CC is on. ECC is lit up now. And GK was not lit up before, and it's still not lit up now. TK TL. The toggle switch, you mean? Yes. Okay, so now we're on the same page. That's good. And then you look at the display menu, check out the toggle switch. Yes. I copy. Then start was depressed. Then I'm pressing stop. I copy. Now it proposes to turn on emergency. The toggle switch says emergency, and it's in the emergency position. Yes, I have done that. Now it's telling me to go back to the initial. Yes, so bring it back to the upper right-hand side position. So in the menu, I have menu and the toggle switch. Is it lit up? Speaking simultaneously. Let me look. The LED. Please wait, there's the sun, and I can get an erroneous config. Okay, yes. Oleg, please stand by, then continue on the go from MCCM. We have to do a couple of steps from the ground. All right, Samantha, how are you doing? So the MLI flaps are closed. Expected configuration. Which and let's have you used. Can you see that? Can you take a photo of the final config? I will try because I'm not sure. I just pressed the button. Oh no, not the one for the camera, but just per the procedure. So I pressed the button number 12. What else shall I do? No, if you turn it on one time, it's on. If you turn it 2 times, then it switches off. Well, I depressed it the first time and it's not lit up. So maybe because you have a visor, you cannot see it so well. All right. Samantha? Well, in February they turned it on. Well, I cannot tell you whether the LED is on. It's not very visible. All right. Well, in that case, we don't need it. Well, can you take a photo of that config? Could you please take those pictures? And then looking towards SM. What exactly? MLI valves and service module. All right. We'll do that. It's not even MLI as much. And once you finish the filming, then please move towards Oleg. All right. Oleg, just proceed and put the stuff for storage. Please stand by. It's just in the opposite direction. Stand by also. All right. I'm by the control panel. Yes. With the sun, it's really hard to see the status of the LEDs. So, Artyom, what are we doing now? Oleg? So, our partners got a message that it's overheated a little bit, so they're sending commands from the ground, and then in about 10 minutes, we'll resume. We need that much time. So we'll be working with the control panel right now. And so we'll do what's required, and then we'll put it into the storage mode. No, prior to that, you can leave it on because we want to see the status. All right. The sun is shining straight at the control panel right now, so maybe it will not be as visible with the direct sun at it. Yes. What you can do. And also, could you please tell us the status of the control panel via the voice loop? All right. Let me have a look. GM. Let me see. The sun is really blinding. All right. TM, then space 1, 2, space is 0, and then nothing but spaces. We copy? How copy? We copy? How do you copy? All right.
Hola, bueno, estamos viendo dos streamings, tenemos abiertos dos streamings al mismo tiempo. No sé en cuál están, tengo los dos chats adelante. En uno de ellos ya estábamos transmitiendo desde hoy temprano una caminata espacial de un cosmonauta ruso, Oleg Artemiev, junto con la primera mujer europea que hace una caminata espacial, Samantha Cristoforetti. Es italiana, es parte de la Agencia Espacial Europea. Están atrasados, están con mucho trabajo. Hace unas horas pusieron 10 nanosatélites en órbita de investigación, o sea, científicos y de prueba, para medir la telemetría durante la caminata espacial. Está muy interesante. Mientras todo pasó, hubo un intento de lanzamiento de SpaceX que hicieron un scrub, o sea, cancelaron faltando 45 segundos para el lanzamiento y quedó para mañana, 24 horas. Mientras todo esto pasa, a mí se me olvidó de que hoy hacían esta prueba de motor también del SLS, una prueba de uno de los motores sólidos, que dicen que son de los motores, el motor quizás sólido más grande del mundo. No lo sé, lo dice la NASA, es posible. Teóricamente, esa prueba ya debería haber comenzado hace más de media hora. Empezamos de apuro, lo armamos, estamos allí conectados, estamos esperando. No encuentro información de qué es lo que ha sucedido. Es NASA y Northrop Grumman. La empresa Northrop Grumman con las comunicaciones es un poco corta a veces. No es como estamos acostumbrados a ver con otras. Voy a seguir buscando y vamos a seguir viendo a ver qué es lo que pasa. El audio que escuchamos son la traducción de lo que hablan los dos astronautas mientras hacen la caminata espacial. Motivos obvios, mi voz no puedo traducirla, estoy en los chats, en los dos, ¿ok? Les agradezco muchísimo el apoyo.
Using the glitter system, and then you can translate towards the circular sector. Will do. I'm closing it right now. I copy, Samantha. We see that you're close to Oleg now. You're back. I am. I'm closing the exterior cover, and with the help of a hook, it's closed. All right. And now, the valve. All right, the camera is on. The camera is on. We copy Oleg. Now, please translate towards the circular sector. And on the way back, please pick up the tethers.
This is Mission Control Houston, just a few minutes shy of the 5-hour mark in today's spacewalk by Oleg Artemiev and Samantha Cristoforetti as they work on the removal and replacement of a protective cover over one of two identical camera light units on either end of the two end effectors or hands on the European robotic arm, the 37-foot-long robotic arm that is attached to the NAOCA multipurpose laboratory module. The replacement of this protective window will improve the acuity of the end effector camera for the various tasks the arm will be working on in future Russian spacewalks to move hardware and payloads around the Russian segment of the International Space Station. The two spacewalkers completed the deployment of 10 small satellites, nanosatellites, part of radio technology experiment data collection. They were deployed in sequential fashion, one after the other, over a 40-minute period.
And I think that's important for a couple of different reasons.
As the first major task of the spacewalk, the two
this sort of close out with the flight termination system that, you know, that's a first-time maneuver for them with SLS, so that might take a little longer. You know, there are things that could still get them in the VAB that just might take a little bit longer and prevent getting out to the pad in enough time to make August 29th. So if you want to plan it and you can afford it.
Also worked to install a platform on the NAOCA module, all this for upcoming Russian spacewalks that will be involved in moving the airlock for the NAOCA module from its current location on the Rosviet module on the Russian segment of the station through the use of the European robotic arm, which also will be used for other outfitting tasks for the new laboratory module that was launched to the station on a Proton rocket from the Baikonur Cosmodrome last July.
Give me your second tether. All right, I see it. It's right here. But it's on a circular handrail here. Yes, I can see that.
The report from the Russian Mission Control Center indicates that that external control panel for the operation of the arm has now been placed in its stowage mode, temporarily put in hibernation, if you will, and thermal insulation has been closed over the NAOCA European robotic arm mechanism at the particular stowage location for that control panel.
Yes, I am. That's very good. That sounds good. All right, I've secured it in place. So we're good, yes. Now we'll rehook. So, do you want to go first or shall I? I can go first, so please move this way and I'll move myself to the left. Then we'll have enough space.
Через 3 минуты у нас тень наступит.
In 3 minutes,
Хорошо.
we'll have the orbital night. Sounds good. We copy. Now, let's have a look. Give it to me. You can use any handrail that is convenient. All right. Give me the short tether. Yes, the short one I've secured on the handrail. All right, and I can also help you out secure. If you can do it yourself, do it. Otherwise, I'm standing by to help. Please wait. I think I should go around it. And this is what I have. Those hooks right by my side. Do you think I should take them? Yes, of course you can take them. All right. Do you want me to give it to you? Well, let's see how many. There should be 4 total, so you can take 2 tethers and I keep 2 tethers. Shall I take the short one or the long one? Either way, you can take a short one and a long one, whatever works.
1 hour, 49 minutes
Okay.
of runtime.
Take them.
Test bay UPS is online with a minimum
Well, just
of 30 minutes
pick them
of
all
runtime.
up and then we'll divide them.
Data center UPS is online with 48 minutes of runtime.
All right, so the lights are on.
T-minus 7 minutes.
All right, now Artyom, are you here?
Связи.
I am. So shall we install the protective window, or are we standing by? No, Oleg. We are ready with the instructions. Did you take those tethers from the platform? We will. Well, Samantha is picking them up, and then we'll divide them. Okay. And regarding the protective window? So then you can work, Oleg, on the protective window, and Samantha can work on the tether. Yes, we can work in parallel. That will work fine. We copy all. We'll do it.
Roger.
T-minus 5 minutes.
I'm Alyssa Lee, and you're joining us
T97
live
test area
here at the
is
Northrop
cleared
Grumman
for
facility in
static test.
Promontory, Utah. Teams at NASA's
High-speed
Kennedy Space
operators
Center in
verify
Florida are
systems.
preparing for the first Artemis launch. And we're here in Utah as teams evaluate materials and processes for future booster designs. We are moments away from a
All
hot-fire
high-speed
test
systems
of a
are
Space
streaming.
Launch System booster motor for those future Artemis missions to the moon. Today's test is called Flight Support Booster 2. We did see a delay of this test today, but we are here and we are ready to fire up this booster. The booster motors for NASA Space Launch System are the largest, most powerful ever built for flight. SLS has 2 solid rocket boosters that flank either side of the rocket. And for 2 minutes today, we're going to see the power of just one of those here in the Utah desert. If you're just now joining us, we're about 5 minutes away
The new
from
ones,
the Flight Support Booster
taking the
2
new
test
one?
in Utah.
Yes.
The booster motor
And
used
the
for
old
today's
one.
test
Yes,
is locked
Samantha.
to the test stand just behind me.
Speaking
Be sure
simultaneously.
to follow us on
Inaudible.
social media at NASA
What did you
Space
say?
Launch System on Facebook
Artyom,
and
please
NASA
repeat.
SLS
Did
on
not
Twitter.
copy.
But no matter where you're watching, you can ask us more questions by using the
Yes,
hashtag
Samantha. What I was
AskNASA.
trying to say is
We're
that
going to have some booster
Samantha
experts
pick up
join you here
all
after
the
the test
tethers,
to answer
the
those
old
questions.
ones, the new ones,
And now I'd like to
all.
introduce you
are
to
go.
a special
All
guest
right,
with
I'm
me
doing
today.
my best.
This is Reed Wiseman, NASA astronaut, engineer, aviator, and chief of the astronaut office. It's an honor to have you here today, Reed. Thank you for joining us.
You bet. It's great to be here.
Yeah. So we did see a delay today. Can you explain more about what that was about?
So what we were told is they were having trouble communicating with a few of the cameras that are up at
5
the test
turns.
facility there by the booster, but they're going to proceed without that data because it was not critical for the test. So we're back.
And then we'll install it and at 5 meters.
Yeah, and we're excited
All
to see
right.
it. I mean, it's going to be a great experience. I believe this is your first.
Is this your first test?
It is. It
All
is
right, so
mine.
both of us. This is
Yeah.
our first test. Yes, this is the first time I've been at one of these booster tests, and I just think it's absolutely awesome that we'll be launching Artemis 1 in just a few weeks on 2 of these boosters. So it's really neat to get to be here today.
Yeah, we're excited for launch. Now, can you tell me more about why testing like this is so important?
Because when we put humans on these things, we want to make sure they work. So they're testing a few critical systems on this booster today that's not related at all to Artemis 1, but is related to our future crewed Artemis flights.
Yeah, I think Artemis 3 and beyond is what we're testing for today. And so can you kind of tell me more about what we're expecting to see with this booster test?
About 2 minutes of a lot of heat and fire coming out the back of that motor. And I know about 4 seconds after it lights off, we should feel the pressure wave and hear the sound, much like we were watching a shuttle or an SLS launch at the Cape. I think it's going to be pretty awesome. I mean, the wind is coming down the hill kind of right at us, so it should be carrying the sound down this valley. You can see like literally 1,000 plus employees from Northrop Grumman out here to watch at NASA. So I think it's going to be amazing.
Yeah, and I think the cameras might even shake a little bit from this test. I mean, you got to think about we're only getting a little taste of what we could see at launch. You know, this is only a single booster, and at launch we're going to have 2 of those. So it's going to be a great sight to see.
2, and then the 4 RS-25s.
Bueno, démonos 2 minutos para la prueba de motor. Estamos ahí, vamos a tratar de poner pantalla completa.
What American ingenuity, what the American workforce can put together when we launch Artemis 1 here in a couple weeks. I can't wait to be there to watch it.
I absolutely agree. Well, thank you, Reed, for that great insight. Now remember, we're going to have some booster experts join me here after the test to answer your questions. Use that hashtag AskNASA on social media to send those to us. Now let's get ready to fire up this booster. You're going to hear a countdown from the test conductor, followed by a 2-minute booster firing. We're going to cut away, and we'll be back here after the test.
Commit the motor.
Motor is committed.
Hey, Farmer, I got good news for you all. That object that we were tracking, the
T-minus 60 seconds.
no action tonight. Hey, great news. Thanks for the update. Have a good night.
All high-speed systems are recording.
You as well.
T-minus 50 seconds.
TVC is go for static test.
Houston, and good news from spacecraft communicator Alex Kanalakos.
T-minus 40 seconds.
Se viene.
T-minus 30 seconds. T-minus 20 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
Impresionante. Impresionante esto.
Activate head and
No,
CO2.
el piso, el color del piso.
Activated.
Eso.
Activate quench tool forward command. Activates aft CO2.
No, 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 no. Qué loco. Qué loco.
Activated. Ballistic script has ended. TVC power is disabled.
Ah, sí, a frearlo, vamos arriba. No, a apagar, a apagar. Debe ser dióxido. Dióxido de carbono o algo así para suprimir las llamas.
Plus 160 seconds.
Es instantáneo, es impresionante. ¿Ah? Vamos a repetirlo, vale la pena.
Plus 170 seconds. High-speed data operator, stop recording.
High-speed recording is complete.
Low-speed data operators, stop recording.
Ya terminó para ellos, ya dejaron hasta de
Low
grabar.
speed data recording complete.
Vamos a esperar un poquito más para pasarlo para atrás. Mientras vemos arriba chiquito que Samantha Cristoforetti y Artemis siguen con la caminata espacial.
T plus 3 minutes, 30 seconds. Post-fire crew, report to the instrument room.
3 minutos 30 segundos.
Report to the instrument room.
Sí, esto no es para Artemis 1, obviamente, es para algunos más adelante. Estos boosters originalmente eran reutilizables. Son idénticos al transbordador espacial, solo que tienen un aero más. En vez de tener 4, tienen 5. Son más grandes, la combustión dura más. Y posiblemente los hayan optimizado también.
Welcome back. And wow, what an amazing sight to see. This powerful
Toda esa gente que vemos ahí son empleados de Northrop Grumman, de NASA y algunos invitados.
We just witnessed a 2-minute booster firing of a solid
Fue un show para ellos, ¿no?
rocket. Here with me to talk about that test and to answer your questions, we have Julia Codabande, motor team lead for SLS boosters at NASA.
Esta es la líder de la parte de motor, de boosters.
Rose, chemical engineer.
Y a la izquierda, ingeniera química de Northrop Grumman.
So, before we begin, I just wanted to say, we heard the test conductor talking a little bit before the firing. Can you explain a little bit more about what they were saying? So I'll start with Julia.
Yeah, thanks, Alyssa. Wow, that was fantastic. So yeah, we heard the test conductor before the firing of the motor. She gave the go for test. The test counted down. They committed the motor. They armed the motor, and then at
Porque la orden armaron.
we have out there today 5 segments of solid rocket motor.
Impresionante ese fuego, ese cohete.
A signal was given from a ground controller to an igniter assembly, which in turn ignited the 5
llega la señal a los inhibidores para encender.
We have a nozzle assembly which had a nozzle plug, and that would have come out as pressure built up inside the motor. We also have an aft skirt assembly, and it houses our advanced booster electronic thrust vector control system, and that vectored the nozzle during the test.
For Julia.
Vamos a hablar.
Low speed data recording
Ahí viene encendido.
4, 3, 2, 1, fire.
Activate head end CO2.
Activated.
Activate quench tool forward command. Activates aft CO2.
Activated.
Mientras, abajo de todo, vemos una gran actividad en el booster, en el SN24, en Boca Chica, ¿no? Mientras hacía todo esto conseguí colocar todas las ventanitas, alinear todos los patitos, ¿no?
Plus 170 seconds. High-speed data operator, stop recording.
High-speed recording is complete.
Low-speed data operators, stop recording.
Low-speed data recording complete.
T plus 3 minutes, 30 seconds. Post-fire crew, report to the instrument room. Post-fire crew, report to the instrument room.
Welcome back, and wow, what an amazing sight to see. This powerful solid rocket booster fired up. Again, we're here at the Northrop Grumman facility in Promontory, Utah, where we just witnessed a 2-minute booster firing of a solid rocket booster for the SLS rocket. Here with me to talk about that test and to answer your questions, we have Julia Cotabande, motor team lead for SLS boosters at NASA's Marshall Space Flight Center, and we have Jessica Rose, chemical engineer for Northrop Grumman, for the SLS boosters as well. So before we begin, I just wanted to say, we heard the test conductor talking a little bit before the
We have an Artemis, an SLS program.
8, 7, 6, 5, 4, 3, 2, 1, fire. +5.
Operator enabled to remove CO2 quench tool controls.
Controls are enabled.
Open the accumulator enable valve.
Accumulator is enabled.
Activate aft deluge.
Aft deluge activated.
Activate forward deluge.
Forward deluge activated.
Activate head end CO2.
Activated.
Activate quench tool forward command. Activates aft CO2.
Activated. Listed script has ended. TVC power is disabled.
160 seconds. Plus 170 seconds. High-speed data operator, stop recording.
High-speed recording is complete.
Low-speed data operators, stop recording.
Going to be something that will get us to the moon and onto Mars.
Low-speed data recording
complete.
Yeah. Awesome.
Estamos escuchando el NSF ahora.
A couple questions here. Feel free to chime in. But let's see. Actually, here's another good one. Do you think that the FAA will require Starship to have a launch escape system, and if so, how would they do it?
Shall I take that one first? Because that has been the question that's been brought up quite a few times. There's no obvious launch escape tower on top of the Starship. It's something where they're probably working more towards the vehicle itself being the abort mode, where if the booster's going wrong, that makes sense. I personally have not got my head around what happens if the actual ship is having a problem during this, at the point where it's still going uphill, and that itself can't be the escape system because that's the vehicle that's going wrong. So I'm not too sure about the nearest plans on that, but I've got a funny feeling Alex might know something.
No, Franma, el SLS que está en Cabo Cañaveral va a volar. Esto de otro. Esto es otra cosa, es una prueba de un motor similar a lo que tiene el SLS.
It's something that's not been answered, has it? It's not been addressed properly, but yeah, I always, it sounds a bit too forgiving, really, but I always take the opinion that there's much cleverer people working at SpaceX on these vehicles than any of us on here, and they will have worked out exactly how that works for crew rating the vehicle. I think the important distinction to make right now is that this vehicle will be cargo, Starlinks, big telescopes, what have you. It will not be launching people for a long time, not after many flights. Elon put it, many flights before they put people on board this vehicle, and by then I'm sure it'll have some kind of system that mitigates the issue of crew safety in the abort scenario.
Alright. We got a couple questions I want to hit really quick. First of all, what is a spin prime test? I guess we should have talked about this slightly earlier. I'm realizing I'm not sure we really went into detail today. So the spin prime test that we saw happen again a few minutes ago is basically flowing liquid oxygen through the engine, through the pumps, spinning the LOX pumps on the Raptor engine, but not igniting anything. So the pre-burners on the fuel side don't light, obviously the main
Tom Bogart de NSF nos está diciendo que hace un rato hubo un spin test y que en realidad no es un encendido esto. Lo que hacen es tirar gases y estudiar cómo funciona los gases de oxígeno sin encender. O sea, no hay forma de que encienda. La otra vez fue un error.
It looked like they were all 6-engine tests. It's hard to tell exactly, but it was definitely multiple engines on those previous tests. So,
Digo, dice que por orgullo era donde baja el SLS. En realidad no. Hay muchísimos contratos, hay muchas empresas involucradas. Hay mucho dinero detrás de eso. Es imposible pararlo ahora. ¿No? Primero, de hecho, están construyendo ya 2 o 3 más. O sea, Artemis 2, 3, 4. Quizás en algún momento lo detengan el programa, pero estar mucho todavía. Tiene que volar mucho esto. La Starship, para probar de que el SLS realmente es obsoleto.
lots of talk about what you think the no earlier than time is, but what's your no later than for the Starship orbital launch test, excuse me. I want to hear
Bueno, y con esto volvemos a la camioneta espacial. Vamos a cerrar este streaming de la prueba de motor. Les agradezco muchísimo por haber estado acá. Vamos a programarlo, seguimos con la caminata espacial. Los invito a que vayan exactamente ese streaming. Voy a colocar la invitación que vayan directo.
But I honestly think they will get a launch this year. I think that's a fair
En directo allí. Un abrazo enorme, gracias. Y seguimos con la caminata. ¿Cuántos son? 53. Vengan al otro streaming. Cuando se corta, queda el enlace directo para hacer clic y entrar.
and we shipped 20 with the ship as well. So right now it's shipped 24 in booster 7, pending booster 7's repairs. It's a long way off yet. So this year, I think that'd be a great achievement if they launched this year on a test flight. And if it takes them a little bit longer and they get a little bit more success out of it, I think that'll play into it very well, because this is going to be a rapid test program once they get that approval to launch the first one, because the second one will follow pretty soon along.